Closures are a way for your functions to keep track of state from function call to function call. Closures usually occur when one function is defined within another function, and that inner function references a variable that's declared in the outer function, one that's outside of its own scope. Take a look at this new counter function in Python. The first thing it does is declare a new count variable and set it equal to 0. Next, it defines an inner function. This function is defined within the new counter function, and we've called it counter. Now, the very first thing it does is use the non-local keyword to tell the Python interpreter, hey, I'm accessing a variable that's declared outside of my scope. So it's just making that count variable available to be accessed. Now, this is something that's fairly Python specific, the non-local keyword. You probably wouldn't need that in another language, something like Go, for example. Now, what it actually does is increment that count variable by 1. Right? Count plus equals 1. And then it returns the new count. And then at the end of the new counter function, it returns the inner function. So it's actually returning a function as a value. To see how it works, let's create some counters. So first we'll call new counter and save the return value into a variable called add health. Now remember, new counter returns a function. Specifically, it returns that counter function. That counter function is now being saved into a variable called add health. Let's call it again, but this time we'll save the returned function into a value called add mana. If we call add health once, it will return 1 because it took that count variable 0, incremented it by 1, and then returned it. If we call add mana for the first time, it will also return 1. That's because each function has its own copy, its own closure around a different count variable. Now, if we call add health a second time, this time it will return 2. And again, that's because the closure has enclosed around the count variable. So add health has its own copy of that count variable that it's going to increment with each successive call. So we can keep calling add health and add mana, and they'll both increment their counts independently. And that isolation is a key feature of closures and what makes them useful. One of the best parts about closures and what makes them useful in real programming is that they allow us to maintain state without having to change the function's signature. So for example, the add health function, it keeps track of and updates this count variable, but it doesn't take a count as input. That means if I have a place in my code where I need to use a function that doesn't take any parameters as input, but I still want to keep track of state, a closure might be a good fit. Now, the obvious downside to this is that the add health and the add mana functions, they're not pure functions, right? They're the antithesis of a pure function because they have side effects. They're mutating something that's outside of their own scope. When called with the same parameters, they produce different outputs. And again, that makes them impure. But the outer function, new counter, that is a pure function because each time you call it, you get a new fresh closure around that count variable that's essentially been set to 0. So if you want to write good unit tests for this type of function, the thing that makes sense is to create a new copy of the closure by calling the outer function at the beginning of the test suite, and then you're starting your tests from scratch each time.